We're here in Colorado for the 2017 running of the Pikes Peak International Hill Climb. Now, one of the standout entrants in the unlimited class is the EPS Motorsport Audi Group B Quattro Replica behind me. We wanted to get a little bit more up close and personal and give you a bit of a rundown on some of the technical details that make this car tick. As I said, it is a replica of the Group B Audi Quattro, and that Group B era is probably one of the most iconic eras in rallying, and of course the Group B Audi Quattro was one of the standout performers in that era. Now, in order to create a replica of a Group B Audi Quattro, it actually requires quite a lot of work. The EPS Motorsport team started with two cars. The front half of the car is from an Audi 80, while the rear half is from an Audi Quattro Coupe. And back in the original Group B days, Audi did this to reduce the wheelbase of the car, and this improved the handling balance as well as vastly reducing the weight. EPS Motorsport have fitted the car with a 5-cylinder inline engine with a 2.5 litre capacity. The engine has been pulled from an Audi TT RS, but it's obviously been beefed up for its new duties. It's fitted in particular with a set of 11:1 forged CP pistons and a set of stronger I-beam conrods. Interestingly, David from EPS Motorsport has chosen to retain the continuously variable cam control on the intake cam. While the engine is fitted with larger, more aggressive cam profiles, retaining the continuously variable intake cam allows the intake cam timing to be moved by the Motec ECU while the engine's operating, and this allows the cam timing to be optimized at every point in the load and RPM range. The result of this is a wider, fatter torque curve than what could be achieved with conventional fixed timing. Again, embracing the modern technology that is now available, EPS Motorsport have fitted the engine with a precision twin ball bearing 6466 turbocharger that's rated to provide up to 95 pounds per minute of airflow. The boost control is via a TurboSmart external wastegate, which is all controlled via the Motec ECU. One of the aspects with a hill climb such as Pikes Peak is that there is a large altitude change, and even at the start of the hill climb we're already at a significant altitude, which reduces the barometric air pressure, the air density, and hence makes it harder for the engine to produce power. One of the advantages with turbocharged cars though is we can manipulate the boost pressure as we go up the hill in order to claw back some of that lost power due to the low atmospheric pressure. One of the keys though when we're doing this is to make sure that we aren't overspeeding the turbocharger. If, for example, we retain a fixed boost pressure from the start of the hill climb to the top, what this actually means is that as we go up the hill, the turbo is being worked much harder, and in order to produce that same boost pressure in the inlet manifold, the turbo speed is also increased. EPS are monitoring this using a KA Sensor's turbo speed sensor. This monitors the turbo speed, and via that information the team can see where exactly they're running in the turbo compressor map, and also importantly they can monitor the critical turbocharger speed to ensure that they aren't going to destroy the turbocharger by overspeeding it. The KA Sensor's turbo speed sensor is actually a pretty unique sensor because not only does it monitor turbo speed, but the tip of the speed sensor also has a temperature sensor, so they're able to monitor both the turbo speed and the air temperature right at the turbo speed sensor. This information is all fed back into the Motec ECU. In terms of boost pressure, at a low boost setting of 1.4 bar or approximately 20 psi, the engine's producing around 600 horsepower. This is approximately the same power levels that the original Group B cars were running. The team do, however, have the advantage of being able to increase the boost to the high boost setting of 1.7 bar or approximately 25 psi, where the engine's producing 800 horsepower. Now, tuning a high boost engine such as this with a high compression ratio requires a really good fuel in order to make sure that you don't run into detonation, and the engine is running on VP Racing Q16 fuel, which has an octane rating in excess of 120. Moving to the other side of the engine bay, we can see an elaborate intake manifold that's designed in order to promote equal air distribution to all 5 cylinders. This manifold also houses an 82mm 4-litre Bosch drive-by-wire throttle body. In terms of fuel supply, we can also see the fuel rail, which houses a set of 5 as-new 1100cc injectors to support the required fuel flow at 800 horsepower. Mounted just behind the throttle body, we can also see a nitrous nozzle, just in case 800 horsepower isn't enough. We'll talk a little bit more about how that nitrous system works shortly. In order to make sure that the engine remains reliable, the factory wet sump system has been removed, and in its place is a dry sump system, and this ensures that regardless of the lateral G-forces being applied to the car during hard cornering, that a constant supply of high pressure oil is always available to the engine bearings, and this is essential for long-term reliability and competition use. The oil reservoir is actually now mounted in the rear of the car, and this also aids weight distribution. One of the novel aspects of this car, which was also taken from the original Group B rally cars, is the works designed strut tops, and these actually allow the strut location to be really quickly changed just by removing a pin, and this allows the caster to be changed between 2 settings. And this was done in the original Group B cars to very quickly change the configuration of the car between gravel and tarmac. In a gravel application, the cars were set up with less caster, while for tarmac use the caster was increased. The brake and wheel department is another area where the team have strayed away from being completely accurate to the original Group B cars. Because this car is developed solely to run on tarmac, the team have chosen to fit a set of 18-inch rotiform wheels, and housed beneath those wheels is a large set of Alcon brakes with 6-pot calipers on the front and 4-pot on the rear. This ensures that at a high-speed event such as Pikes Peak, the car can always reliably be stopped. Let's jump into the car now, and we'll discuss some of the features available to the driver. Before I get too tied up on the actual details, we'll just cover off the electronics package fitted to the car. As EPS Motorsport are a Motec dealer, understandably the car is fitted with a full suite of Motec electronics. The ECU controlling the engine management is a Motec M150, and there is also a Motec C127 driver display and logger. Controlling the power distribution to all of the electronic components and the engine is a Motec PDM30. So this does away with the requirement for conventional fuses and relays, and everything is done in solid state. There's also a lot more control with a power distribution module when compared to conventional fuses and relays. The power distribution module also interfaces nicely with the Motec CAN-based keypad to control all of the outputs from the PDM. We'll cover that off in a little more detail shortly. Now let's focus for a moment on the steering wheel, and we can see that there are a number of buttons on the steering wheel. On the top left we have a button that sets a lap beacon, so this can be used to insert timing information into a log file. Below this we have a page up and page down button, and this just cycles through the information that's displayed on the bottom line of the Motec C127 dash. On the right hand side in the middle we have a button that changes the mode of the dash display. So this can be used to display various information depending on whether the car is being warmed up, whether it is in a practice run or whether it's in competition. Directly above this, the blue button is used to trigger the nitrous control, and I'm not going to press that right now. Below that we've got a 5-position switch which can be used to adjust boost while the car is being driven. The boost itself is controlled via the Motec and is closed loop boost control. So what this means is that the driver can set a boost target through this switch, and the ECU will then adjust the boost control solenoid in order to achieve that specific boost target. So when set up correctly, this can give very, very accurate boost control even as atmospheric conditions change. To the right of the steering wheel we can see quite an elaborate gear lever which is connected to the drag power 6-speed sequential dog engagement transmission. This is quite a unique transmission because this car is 4-wheel drive, so the transmission also houses the front differential, and then the drive shafts come out of the transmission to the front wheels. Now the dog engagement transmission is controlled via this gear lever, and it's fitted with a KA Sensors strain gauge up in the top of the gear knob. Now this strain gauge tells the Motec ECU whether the driver is pulling back on the gear lever or pushing forward. With this combination, what we can do is change gears on an upshift without lifting off the throttle. The driver can simply stay at full throttle, pull back on the gear lever. This sends a signal to the ECU telling the ECU the driver is requesting an upshift, and then the ECU will momentarily cut the ignition in order to allow the current gear to disengage and the next gear to be engaged. This can all happen incredibly quickly as well. The benefit with a turbocharged car of flat shifting like this is that the turbo will not fall off boost as far as if we actually had to back off the throttle and use the clutch for the upshift. When we press forward on the gear lever, this will tell the ECU that we're requesting a downshift, and in this instance, because the car is also fitted with a drive-by-wire throttle body, the Motec ECU will automatically blip the throttle to match the revs for the next gear down. What this means is that the driver doesn't need to heel and toe on the downshift. He can concentrate solely on controlling the car and achieving maximum braking effort. The Motec CAN-based keypad communicates with both the C127 dash as well as the Motec power distribution module, and one of the advantages of this keypad is it is incredibly configurable. You can configure any of the keys to do just about any function that you want to control on the car. For example, we can see that some of the functions on the steering wheel are also doubled up. We can change mode on the dash, and we can also scroll the data. There's also an alarm reset for resetting any of the alarms that come up on the dash while the car is running. Now, if we look at one of the other controls here, if we press the engine fan, you can see that this automates the process. It starts with one fan, and then a second later the other fan kicks in, and we see a visual indication of exactly what's happening via the LEDs on the keypad. Understandably, safety is important in any race car, and as you can see, I'm surrounded by a really intricately constructed roll cage. This roll cage is constructed out of T45 tubing, and it's all been TIG welded. Now, as well as the roll cage, there is also a couple of fire extinguishers installed in the car. There is a 2 kilogram handheld extinguisher as well as a plumbed system behind me. Now, the plumbed system is plumbed through to the engine bay and can be activated via a switch on the dashboard or an external switch in the case of a fire. As well as the fire extinguisher system behind me, we can also see a carbon fibre nitrous bottle. And I just wanted to discuss how the nitrous system works on this car. It is only a relatively small nitrous shot, around about 35 horsepower, and the nitrous is being used primarily for anti-lag. So in this instance, when the driver goes to full throttle but is at low RPM where the turbo isn't making full boost, the nitrous will come on, and this helps spool the turbo up to make full boost really quickly. Once the turbo is on full boost, the nitrous system can be deactivated. And between the fact that the nitrous system isn't activated all of the time, as well as the fact it is a very small shot, this means that the 10-pound bottle of nitrous will actually last quite a long time. Now, on the nitrous bottle, we can also see there is a heater blanket fitted, and this is used in conjunction with the pressure sensor fitted to the bottle in order to control the pressure in the bottle to a fixed value. This makes sure that the nitrous operation is always really consistent in terms of the power that it's delivering. The nitrous system is a dry system, which means that the jet on the engine, the jet on the intake pre-throttle body, is only delivering nitrous, and the required extra fuel is controlled via the Motec ECU and delivered via the injectors into the engine. Moving down to the floor of the car is fitted with a tilt-in pedal box, and first of all I just wanted to talk about the throttle pedal. Now obviously, as we've already talked about, this car is fitted with a drive-by-wire throttle, and in order to give the ECU the signal that it needs, there is a linear potentiometer fitted to the throttle pedal. So as the driver presses the throttle pedal, this sends an electronic signal through to the ECU which demands a certain throttle opening. Moving across to the brake pedal, this allows the driver to make adjustments to the brake bias front to rear to suit the conditions, but this also interfaces via a Bosch Motorsport ABS unit, which we can see mounted on the top of the transmission tunnel. Now this is very different to most road car ABS systems in that it is purposely designed for motorsport use. It also allows the driver to adjust the ABS function via this multi-position switch up on the dash. This allows the ABS effect to be adjusted to suit different conditions and different grip levels, be it wet or dry. So there's a little bit more insight into what makes the EPS Motorsport Audi Quattro Group B Replica tick. We love the quality of this build as well as the attention to detail, but it's not just a rolling work of art, it also performs when it counts. The car's already been exceptionally fast in practice leading up to the Pikes Peak hill climb, and we wish the team all the best for the actual event on Sunday.